Hey guys, I'm going to go over the 8.1 and 8.3 homework. 8.1 talks about average value, and what should you know about average value of a function, and that is a certain formula. So the average value of a function is equal to 1 over b minus a times by the integral from a to b of f of x dx. That's really all it is. And it's just saying that it's just the average value of whatever f is. So without any context, it's basically the average y value. So the average value of the function f over the interval from negative 2 to 3 is negative 6, and the average value of f over the interval from 3 to 5 is 20. What is the average value of f on the interval from negative 2 to 5? So it gives us two different average values, so negative 6 and 20, but of course, so the average value is negative 6 over this interval and 20 over this interval. What is the average value over this interval? So it sounds like we're going to set up an algebraic equation where we're just going to have to find a missing piece. So let's start with the first interval that they give us. So if you just write this inside the formula that we have here, you can find what you're missing. So we know that the average value is 6. We know that the interval from b minus a, so b minus negative 2, that's going to be 5. And so I know that 1/5 of the integral from a to b of f, not from a to b, from negative 2 to 3 of f of x dx, this is equal to negative 6. Then we have integral from 3 to 5, and so that's from here, and then 5 minus 3, that's going to be 1/2, so 1 over 2, and then, well, not 1/2, it's 2, so 1 over 2 for that part of f of x dx is equal to 20. What is the average value of f over the interval from negative 2 to 5? And so we'll say from negative 2 to 5, that's going to be 7. And then the integral from negative 2 to 5 of f of x dx, what does this equal right here? We'll call this x. So here's what we're going to do. What I think we're going to do is, if I just solve for this integral, solve for the integrals, I think is what we want to do. So times by 5 and times by 2, I get the integral from negative 2 to 3 of f of x dx is equal to, is that negative 35? I can't remember. And then the integral from 3 to 5 of f of x dx, this is equal to 40. And then note how that this integral from negative 2 to 5 would be the sum of these two, because this goes from negative 2 to 3 and this goes from 3 to 5. So that means the sum of these two right here will be the value of this right here. So that's 5. So the sum of these two right here is 5, meaning that this part is 5. So basically what we have is 1/7 times by 5 is equal to x. Oh no, I'm getting 5/7, and that's not here. So I missed something. I bet it's here. When I times by 6 times 5 is 30, not 35. Oh man, imagine messing up the arithmetic on a calculus problem, not even the algebra, the arithmetic. Alright, so then that would mean that this would be 10. So that's going to be 10. And that's going to be 10 right here. And that's going to give me 10/7. And there's our answer right there. Alright, the intensity of light at a distant x meters from a source is modeled by the function r, and r of t is given here, where k is a positive constant. Which of the following gives the average intensity of the light between 4 meters and 6 meters? So, average intensity of light. What is the average value of r? So, between 4 and 6. So, you're just using this formula right here. So, you can say the integral from 4 to 6. Now, that length of that interval is 2, so 1 over 2, and then of k over x squared dx. What is the average value? Now, we're just going to work with this constant right here. I mean, you could pull it out right here and make it k right here. It's not going to matter, but we just got to find the antiderivative of 1 over x squared, and the antiderivative of 1 over x squared is just negative 1 over x, right? And then this will be from 4 to 6. And so we're going to plug in 6, and then we're going to plug in 4. So we have 1/2, we're going to have negative 6 over x plus 4 over, I'm plugging it in for k. What am I doing? Negative k over 6 plus k over 4. C? Yeah? I think it's C. Okay. Alright, this one will be using a calculator. Let f be the function given by this one here. What is the average value of f on the closed interval from 1 to 3? So that has an interval of 2, so 1/2 integral from 1 to 3 of sine of 2x times by cosine of 1 plus x dx. This is a product. So that means our methods are limited as to how to evaluate this, but it is a calculator question, so why even bother trying to find an antiderivative of this product when I can just use a calculator? So we'll go here. Just don't forget about that 1/2, so you can do 1/2, we can do 0.5 right now. We'll do math, option 9, integral from, I think it's from 1 to 3. And it was sine of 2x. And then times by cosine. I think it was like 1 plus x. I think. 369. So B. There you go. Okay, so just keep in mind, average value, that's what you're looking for. It's just this simple equation. It's just the 1 over the difference between, it's just 1 over the interval. B minus A means the length of the interval. So like whenever I was solving for the interval here, I wasn't doing 3 minus negative 2. I just know that that's an interval, that's a length of 5. And so 5. 3 to 5, that's a length of 2, so 2. Negative 2 to 5, that's a length of 7, so that's what I do. Alright, I think we're probably going to be switching here. So for 4, for time t is greater than or equal to 0, the velocity of a particle moving along the x-axis is given by v of t. The initial position of the particle at time t equals 0 is x equals 4. That might be important, might not. Which of the following gives the total distance? Pay attention. Total distance the particle travels from t equals 0 to t equals 3. So total distance, if you guys remember, yes, you have to have these memorized. Total distance is the integral from a to b of the absolute value of v of t dt, total distance. So we're not looking for position, we're not looking for displacement. We are looking for total distance traveled on the interval. So we're saying here the integral from t equals 0 to t equals 3 of the absolute value of x to the third minus 3x squared plus 2x dx. Okay, so we don't actually have to solve it. I was thinking that. Okay, so which of these matches that right there? And I think it's C right here. So just so you guys know, this first one right here for A, that would be displacement. The next one this right here is total distance, and if you add 4, I don't even know what that gives you. That gives you the total distance traveled plus 4, which I don't know what that would mean. But then for D, this right here would be position. This is the position at t equals 3. So this is the displacement after 3 seconds. D is the position from 0 to 3, given that the initial position is 4. And then C is total distance. Alright, so for 5, it's got one of those lovely ones where it jumps to the other page, so that's fun. For time t is greater than or equal to 0, the acceleration of the particle moving along the x-axis is given here. At time t equals 0, the velocity of the particle is 8, and the position of the particle is 0. What is the position of the particle at t equals pi/4? So I think we did this one in the notes. So if you guys want to refer back to notes, I think we did one almost exactly like this. But so this is going to be a two-step thing, because all we have is acceleration, and we're trying to find the position. So we're going to have to go 2 layers back. So the initial, so velocity is a. So I'm pretty used to doing this formula. So I know that it gives me an initial value for my velocity. So that means it's going to be 8. And then that's going to be 8 plus the integral from 0 to pi/4. Yep, 8 plus the integral from 0 to pi/4 of a of t. So that's going to be cosine of t plus t dt. Remember that this is just from a formula that they give you. Formula that you should know. And that formula is, right here. Now, we're using velocity, this right here, so that means that if you apply the same concept, so like for this one up here, you were given velocity, and this would give you position. But we have acceleration, but the same information right here will give you velocity, and then we'll get some more information where we'll do velocity to position. And so, yeah, so let's go ahead and solve this right here. This will be equal to 8. Now we need the antiderivative of cosine of t, so that's going to be plus, and then we're going to do, I'm going to use parentheses here because I don't want to include 8 as part of my antiderivative that I'm going to take over here. It isn't, and so keep that in mind. So whenever I evaluate these values here, but in any case, so the integral of, I think it's going to be sine of t plus 1/2 t squared, and this is from 0 to pi/4, and then we're going to plug in pi/4 and 0. Now I can already tell you that by plugging in 0, we're going to get 0. So I just have to plug in pi fourths. So we're going to get equal to 8 plus sine of pi over 4 plus 1/2 pi over 4 squared. And that's going to be equal to, oh man, do I want to do it this way? Okay, I'll try it. I don't know where this is going. Sine of pi fourths is root 2 over 2. Root 2 over 2 plus 1/2, and that's just going to be pi squared over 4. Shoot, I don't think I wanted to do this. I think because this right here will tell me, it won't tell me what I want, which is the position of the particle at time t equals pi over 4. I need a velocity equation, not an actual value, so I don't think I want to do that. I think what I want to do, rather, is just evaluate this to x, because I'm trying to get a function, not an actual value, to x. Yeah, that's what I want to do. I want to do that, yep. So then this makes my job easier, because then we'll just get, we'll say this right here. We'll say this is what velocity, we'll say v of x is equal to all of this right here. That's what we want to do. Yeah, that makes sense, because then that's why we have the 8 here. We have the 8 here because that tells us the initial velocity. And that's why I don't place pi over 4 here, because I already have a value for the velocity at the velocity at 0. So t equals 0, the velocity is 8. Yep, the velocity is at 8 to x. And that's going to give me a function here, rather. So that's going to be equal to 8. Now I just have to plug in x, because like I said, plugging in 0 just gives me 0. So sine of x plus 1/2 of x squared. This is what velocity is. So this is v of x right here. Now I'm also just going to say this is v of t. Should I? I don't know. Let's just roll with it. Doesn't matter. T is just a dummy variable like it was here. T was the dummy variable. It got substituted for x anyways. So here is my velocity function. Now what is the position of the particle at t equals pi over 4? So then if I want position, I think I can do x of pi over 4. And that's going to be equal to, well, we have the position at 0, which is the position of the particle is 0. So it's just going to be 0 plus the integral from 0 to pi over 4. So now that I actually want the value at pi fourths right here, yeah, because I actually want the value at pi fourths. I didn't really want the value at pi fourths for velocity. That's not what I was looking for. I wanted an actual function so that I can use it to find the actual position. So the integral from 0 to pi over 4 of 8 plus sine of x plus 1/2 x squared dx. Okay, so let's try this one out. And that's going to be equal to 8x. I think we're going to do minus cosine of x plus 1/6 x to the third from 0 to pi over 4. So let's plug in pi fourths. So plugging in pi fourths, I get 8 times by pi over 4 minus cosine of pi over 4 plus 1 over 6 times by pi over 4 to the third. Minus, if I plug in 0, that will be 0. If I plug in 0 here, cosine of 0 is 1. So 0 minus 1. And then if I plug in 0 here, then I'll get 0. So essentially, all that I get is that to be plus 1. This becomes 2 pi. I'm going to keep an eye out over here. So I see 2 pi, and then I also see plus 1. I know that cosine of pi fourths is root 2 over 2. Cosine is still root 2 over 2, right? And then, let's see, then we're going to do plus, this is going to be pi to the third. I'm going to need a calculator for that part. We're going to do 4 to the third, and that's 64, and multiply that by 6, so I get over 384, then plus 1, so the answer is C. Alright, cool. That was a fun one. I like those ones. And I would say of all the questions that we've done so far, I would give this one a star in terms of importance of knowing how to do, because they always like to do questions like this on the AP exam. I would say at least once in the free response. So really important that you know how to, I don't know if they'll make you do it twice like we did here, but basically you're just using the same formula twice. Once where you're trying to convert acceleration to velocity. Now you're just trying to get the function of velocity here, so you integrate to x, but then we use this right here, velocity, to get position, and since we want an actual value of position, we actually use pi fourths. So this is really important. I also think 1 through 3 is important. Anyways, okay, we'll jump to 6. For time t is greater than or equal to 0, the acceleration of particle. Oh, they have another one like this. All right, cool. More practice. Let's go. So for time t is greater than or equal to 0, we have the acceleration. So let's do the same thing. This is good because I'll probably do like a problem like this on the test anyway. So since we want velocity first, we'll do what's the initial velocity that they give us at t equals 0. Velocity is 2. So we can say that v of t is equal to 2 plus the integral from 0. We're using 0 since we start, this is the initial velocity at t equals 0. And then we'll just go to x because we want a function out of this of 12e to the negative 2t plus 18t dt, and this is a very small space, so sorry. 2 plus, now the antiderivative of this is going to be negative 6e to the negative 2t plus 9t squared. And that's going to be from 0 to x, so it's going to be equal to 2 minus 6e to the negative 2t plus 9x squared. This is our velocity, v of x. So then if I want to find the position, what is the position of the particle? So we'll say x of 2, and that's going to be equal to 4 plus the integral from 0 to 2 of 2 minus 6e to the negative 2x plus 9x x squared dx, and that's going to be equal to 4 plus the antiderivative of 2 is 2x. That will turn into plus 3e to the negative 2x, and then plus, I think we'll say 3x to the third. And then from 0 to 2, that's going to be equal to 4 plus, we're going to plug in 2. So if I plug in 2, we're going to get 4 plus 3e to the negative 4 plus, that becomes 8 times by 3, so plus 24 minus, and now we got to plug in 0, but we have, okay, this 4 doesn't count as part of my antiderivative, by the way, so I'm plugging in 0 here. That becomes 0. And then I'm plugging in 0 here. That will make this 1. So then plus 3. And then plus 0. So we just have a bunch of constants that we need to add together. So I see 4 plus 24 minus 3. And I didn't get any constant that they have. Awesome. Awesome, awesome, awesome. So, 2 to the third is 8. 8 times 3 is 24. I got 29. Uh-oh. 24. Plug in 4. Plug in 2 here. Antiderivative 2 is 2x. That's going to be 4. Oh no. I don't know. Maybe you guys were doing this with me and then maybe you guys caught the mistake. I hope you guys did, because I don't really want to go back. Ugh. Oh man, what a mess. Let's see, v of x, 2 minus 6, 9x squared. Just going back and checking my work. Let's see what I did here. So I plugged in x. Oh no. There we go. I didn't plug in 0. Oh man, I plugged in x, I did not plug in 0, because if I plugged in 0, so now I'll get minus. If I plugged in 0, that becomes 0, yes, but this right here would become, so in total it would become plus 6, which means that this becomes 8. That becomes 8. There's my mistake. So x of 2 will be equal to 4 plus the integral from 0 to 2 of 8. Yeah, of 8 minus 6e to the negative 2x plus 9x squared dx. Okay. I probably didn't need to erase all that because I just needed to change that. Oh well, too late. Alright, so that's going to be equal to 4 plus 8 x minus 3e to the negative 2x plus 3x to the third, and that's going to be from 0 to 2. Okay, and then we'll plug in 2, so it's going to be equal to 4 plus, we have 16 minus 3e to the negative 4. And if I plug in 2, again, that's going to be so plus 24 minus, and then if I plug in 0, remember, so starting here, so I plug in 0, those two become 0. This becomes, so it's just going to become plus 3. So plus 3, let's see if those add up. 4 plus 16 plus 24 plus 3. No, it doesn't. Guys, what do I keep messing up here? Now I have 47 as my constant. What do I keep messing up here? I don't know. I really don't know. Position of the particle is 4. Integral from 0 to 2. It worked out so well in the previous problem, and now I'm making mistakes here. Maybe I added wrong. 24 plus 3 is 27. Plus 16 is 43. Plus 4 is 47. Alright, let me just double check my work one more time, I guess. Let's try a different method. How about this? How about this right here? So we know that I'll say V of t this time. V of t is equal to, the velocity is equal to negative 6e to the negative 2t. We have plus 9t squared, and then we have plus 8, right? Yeah, plus 8. So let's try something different this time. Maybe this will get rid of our mistake, but let's say that we take the antiderivative, just like, so we'll just take we'll say the antiderivative of this right here, and then we'll give it a plus c. How about that? Instead of using, so we'll use kind of like this method right here. So what's the antiderivative of this right here? It's going, so we'll say x of t is going to be equal to, so it's going to be equal to 3 e to the negative 2t plus 3t squared plus 8t, and we'll say plus c. Oh man, this is making me so angry because it should work out and it's just not. So then I know that the initial position, so at t equals 0, it's going to be equal to 4. So I know that this will be equal to 4, that the position will be equal to 4 when t is equal to 0. So 3 e to the 0, and then 0, and then plus c. So then c is going to be equal to 1. So go ahead and plug this back up here to be 1. And then I can say that, let's do x of 2. So then I plug in 2. So when I plug in 2, I get 3e to the negative 4 plus, shouldn't that be cubed? That should be cubed. No, it's not. This one should be cubed right there, not the other one. So then if I plug in 2 right here, I should be getting the same numbers, right? I'm getting the same numbers as I did before. So I plug in 2 to the third, it's 8. 8 times 3 is 24. So I'm going to say plus 24. And then I plug in 2 here, that's going to be plus 16. Plus 1. Maybe that's different. It was like 3 before, but that might get us what we need. So 24 plus 16 plus 1. That's equal to 41. So 3e to the negative 4 plus 41. There you go. It's C. Sorry, that one took way longer than it should have. All right, for 7. For t is greater than or equals 0, the velocity of a particle moving along the x-axis is given here. The initial position of the particle at t equals 0 is here. What is the displacement of the particle? So just so you know, displacement shouldn't matter what the initial was. I don't think anyways. So the displacement is going to be equal to the integral from 0 to 5 of v of t dt. So using the calculator, so arctangent t squared plus t minus 1. T squared plus t minus 1. So we're just going to do math. Number 9, from 0 to 5 of arctangent of x squared plus x minus 1. Okay, and I got 5.504. There you go. So it's B. Don't even need this right here. It's not relevant whenever it comes to displacement. It would be relevant if it was talking about position. Okay, so for 8, the rate at which people arrive at a theater box office is modeled by the function b, where b of t is measured in people per minute. So b of t, this is people for every minute. That means the value underneath the curve is the number of people. Which of the following is the closest number of people that arrive at the box office during the time interval from 0 to 20? So let's split this up right here. I think we can do that right there. So this is 5, 10, 15. 15 times by 5, and that's going to be 75. This would be 75 too, because it's the same amount of space as this right here. 1, 2, 3. So this will be 75. And then this right here, bring that down. It's just going to be 1. I'll just do so the base is 5. So 1/2 of 5 times by the height, which is 15. So 37.5. So I think we can just add all that up. So 75 plus 75 plus 37.5, and I got 187.5. So we'll go with D right there. For 9, a cup of coffee is poured and the temperature is measured to be 120 degrees Fahrenheit. The temperature of the coffee then decreases at a rate modeled by R of T equal to this right here, degrees Fahrenheit per minute, where T is the number of minutes since the coffee was poured. What is the temperature of the coffee in degrees Fahrenheit at time T equals 1 minute? So the function that they gives us is the rate that it changes starting at t equals 0. So how about we just do the integral from 0 to 1 of r of t dt. Now, the initial temperature was 120. So we're going to have to do 120 minus the change in temperature. So this right here, since r of t represents the rate of temperature, the integral will be equal to the change in temperature. And this was the initial. So just use a calculator. So we'll do 120 minus integral from 0 to 1, I believe it was, and the function is 55 e raised to the 0.03 negative 0.0303 x squared. Enter, and I got something that's not there. This is not my night, guys. What in the world? I am doing so bad on my record tonight. That shouldn't matter. Integral math, number 9. Integral from 0 to 1, 55 second e raised to the negative 0.03 x squared. 120 minus that answer, 65.545, 65.5. How are they not rounding to 3 decimal places? All right. Water is leaking from a dam during the particular week at a rate modeled by the function f given here, where ft is measured in gallons per day and t is the number of days since the start of the week on Sunday. How many gallons of water leak from the dam Tuesday through Thursday, days 2 to 4? So I think here we can just do the integral from 2 to 4. Since I don't think it's concerned about the initial, it doesn't even give us initial value of f of t dt. I think we can just do that right there. So math number 9, 2 to 4. And then 5 plus x divided by 4 minus sine of x squared over 5 minus sine of x squared divided by 5. 10 point, 1, 0, 1, so B. All right, and that wraps up everything for 8.1, 8.3.